So we have to obtain the integral of this function, or rather an antiderivative of this function given here. And you know, we can't really quickly see in our heads that what is this portion the derivative of. Many of you may be able to do that, but it's not really that obvious to most of us. So let's see, or let's write u as sine x. So when we write u as sine x, then what happens is du dx is what is cosine x, right? Now we can write everything in terms of this new variable now. That is, we got u cubed here. This cosine x is du dx. And if you look into the notes that I have posted for you, let me enlarge it first. Okay, that is, let me increase the size of it. All right, so what happens here? That this portion here in terms of u became this, and we can treat this, this as differential. So this will become what simply afterwards? Simply u cubed du, which we know is u to the power 4 over 4, and of course we have to write an arbitrary constant at the end. So if we go ahead and write the value of u as it was initially, or it wrote that in a different form, I just did that according to, just wanted the computer to give the answer, and it just went in its own different way. All right, you can just do it at your own leisure. Okay, and this is how much? If I had substituted, instead of asking the computer for it, I could write it like this. Okay, so let's see how do these two answers, or these two different answers behave. Okay, say we have to check an identity. So here we go. So here is a graph of this answer here. Now let me go ahead and graph the other answer. Okay, and let's graph that in a different color. We are done with the question. We are just doing it for our own curiosity. So you can see the two are different only by a constant, and for antiderivative, yeah, that's expected. So anyways, so an answer for the antiderivative is this, another answer is this. Now let's work with more examples to see how this method of substitution works. Like what we did was we substituted u equals sine x. Now when I write a new question, you may do this, that is, you may pause the video and then try it on your own first, and then see whether our approaches match or our answers match. Sometimes answers may come out to be in slightly different forms. So yeah, let's continue. So say we got this portion here. Okay, so now in here, if we have to do the substitution, what looks like a good candidate is this. And notice, a reason for this being good candidate is this, that derivative of 1 plus x squared is 2x, and x is sitting right here. 2 is a constant, so we can handle that really easily. So let me enlarge this again. Okay, so sorry. So if we treat this as u, then what would happen is we have 2x dx equals du, or in other words, x dx is how much? 1/2 du. So this will simply become, when we are writing it in terms of u, this will be square root of u for x dx, or for x dx. I mean, I could have brought this x over here, but you're all mature enough to see that. Okay, so that will be 1/2 du. Okay, and then I can pull this 1/2 out, and then what I get? I simply get the antiderivative of square root of u with respect to u, right? And then what this will be, this square root of u is the same as u to the power 1/2. Okay, so we got u to the power 1/2, and we can simply use the power rule here. So that will be 1/2 times u to the power 1/2 plus 1, right? And then we divide by the same quantity. Okay, so here we are. Okay, plus a constant, which will be, or in other words, this is going to be, we have 1/2 again. All right, and then what we got? U to the 3/2 in the numerator, and then 3/2 in the denominator, and this 2 and this 2 will cancel each other. So what we get finally? We finally get 1/3 u to the power 3/2 plus a constant. Okay, and then writing u back as 1 plus x square, what our answer will be? Our answer will be simply 1 plus x square to the power 3/2 plus a constant for this antiderivative. Now there is another video that I'm going to let this one follow, and there are many written examples, so do the quiz on the WebAssign and let me know if you have any questions. Okay.